Hello everyone, my name is Arohi and welcome to my channel. So guys, in this video I'll show you the practical implementation of Super Resolution GAN Networks, SRGANs. So guys, in my previous video I have explained you the theoretical part, layer architecture of SRGAN, and if you want to go through that first, then link is given in description section, you can check that. Today I'll focus on practical implementation and I'll show you how to work on your custom dataset, how to train SRGAN on your custom dataset, and then how to test your model, how to see the result, all these kind of things. Okay, so let's start. So guys, whenever we talk about any AI model, the first thing is dataset. So let me show you the dataset on which I'm working. So this is the folder in which I'm working, and all these files and folders are required. So let's see all these folder one by one, but first of all we are checking the dataset folder. So this is my dataset folder. This I have created myself, and under that you can see this train_HR. HR means high resolution images, and then I have another folder with the name of train_LR. LR means low resolution images. Let me open these both folders and show you first. So this is my train_HR, right? So over here you can see I have images of cards, and I have around 135 images of cards. Okay, this is my data set. So I'm using a very small data set. This is just for a demo purpose. I'm just showing you the functionality, how it will work. Okay, so we are having 136 images under this train HR folder. So now guys, when we want to work on SRGAN, so SRGAN needs a data in the form of pair. Means if you have a high resolution images, then you need another folder in which you will have the low resolution images. So all these images which are present in train HR, right? So these are my high resolution images. Now you have to create another folder in which you will store your low resolution images like this. So this is my train_LR folder. So you can see in this train HR, okay, let's see the images. So all these images are of size 256 into 256. So high resolution images are of size 256 into 256. So guys, one thing to note over here, I'm not using a very big size, because then while processing, while generating, while training your model, it will take so much of time. Okay, so right now I have decided to go with this side. For high resolution images, I'm using this size 256 into 256, and SRGANs upsample the image 4 times. Remember, in my theoretical class, also in my last class, I've told you that SRGAN will upscale the image 4 times. So that means if your image size is low resolution image is 64 into 64, it will upsample it 4 times. Okay, that means it will become 256 into 256. All right. So right now my high resolution images are of size 256 into 256, and then I have downsampled these images over here in this folder, and over here you can see the size. These images are of 64 into 64 size, right? Downsampled. First I collected the images from internet and I placed high resolution images, and I have resized them into a 256 into 256 size, and I placed those images in the train HR folder. Okay, then I have created another folder with the name of train_LR. In this folder, what I have done is I have the images which are in train_HR folder, I downsampled them 4 times, right? So if you will downsample the image which is 256 into 256, if you downsample it 4 times, means you'll reduce it 4 times, you will get 64 into 64. So all those images are here, over here. Let's open one images. Okay, just give me a second. So this is my image which is of size 64 into 64. Now let's open the same image. Okay, just a second. So this is my image which is of size 256 into 256. So in our today's class, what we'll do, we'll give the input to our SRGAN. That input image will be of this size 64 into 64. And it will give you a output image, super resolution image of size 256 into 256, right? This will be the input to our network, and this is the expected output from our network. All right, so guys, this is what our dataset looks like. So I have shown you these two things, And in the same way, I have these two folders. Right now you don't need these folders. This first folder is for testing purpose and this is for validation. Okay, so right now for training your network you only need these two folders. Okay, so train underscore LR have these images, train underscore HR have these images. Okay, and we have images in the form of pair, means the images which are present in train underscore HR, they are high resolution images of size 256 into 256, and in train underscore LR folder we have all the similar images but we have downsampled them with a factor of 4. Okay, this is my data set. In the same way you can create your data set. All right, so now we know about the data set. Next thing is, guys, here you can see this mode and main. These two files are important. There are rest of the files, but there is no need to do any change in those files. You only need to know about these two files. Okay, let me show you these files. So I'm showing you a mode.py file. So now guys, mode.py file, what is the function of this file? So there are three modes of this code. First is training mode, you can train your model. Second is test mode, means using this algorithm you can perform testing on your unseen data. Once you train your model, then you test your data. Okay, and there is another mode, test only. One is train mode, second is test mode, third is test only mode. So train mode, it is clear, you can train your model. Okay, and once you train your model you will get a trained model, and that model will be in this folder. Your trained model will be in this model folder. Let's open it and see. Over here you can get your models. Okay, so once training is completed, now you want to test your model. There are two ways you can test. One is you only want to see the output images, means you have given the input of 64 into 64 and you are only interested in seeing that what will be the output image, means the image super resolution image which will be of size 256 into 256. So what will be the image? One thing is this, if you want to get only the output image, then you can use test only mode. Okay, but if you also want to see the PSNR values also, and you want to store those PSNR values in a separate file in order to know like what is the PSNR value after every for all the images, then you can use a test mode. Okay, so let me show you the folder. Okay, so first this train function is for train mode. In this we have explained, we have written all the things which is required for training. Okay, you can see, okay, till here one function for training, and then we have another function for test. This test function will perform the testing and results will be, the output images will be stored in a result folder, and you will get a corresponding text file in which all the PSNR values will be stored. Okay, let me show you that also. Okay, you can see here result.txt. When you will open it, you can see the PSNR values like this. You'll get PSNR values. All right, and third mode is the test only mode. This test only mode will only perform the test on the unseen images, and results will be stored in a result folder only. Okay, so these are the three modes. Don't worry guys, I'm just giving you an overview. We'll see the practical implementation, okay, in a bit. So there is another file with the name of main.py. If you want to increase the number of epochs or decrease the number of epochs, you want to change the batch size, and if you want to give path of your dataset folders, all those things you'll mention here. And you can see all these modes we have called over here: train, test, and test only, the modes. Okay, and by default if you run this main.py file, training will start. But if you want to do test or test only, then you have to define the mode with the code. Okay, that I'll explain you. So these are the two files. Now let me show you how you will train your model. Okay, what is the command for that? So Python main.py, then this is the argument LR path. Over here you have to provide the path of the dataset where your low resolution images are. Okay, train underscore LR. Remember, I've shown you this over here, train underscore LR. I have given the path of this. Okay, and then GT underscore path means your current ground truth, the real high resolution images. So our real high resolution images are in this folder, so we have given the path of that. So when training will start, and guys, training will take time, so it is a very time consuming process. So I have only trained it for 1500 epochs, but I am getting a result, but results are not very good. Okay, so I'll show you in a minute like what kind of results we get. But guys, I have only trained it for 1500 epochs, so if you want to improve the results, you can train it for more epochs. Okay, so with this command you'll train your algorithm, and this main.py, and guys, see, I'm not giving any mode over here because by default the mode is train only. Okay, so after training, after running this command, when training will get completed, you will get, and inside this model folder you will get your model. Okay, and once training is completed, now the next task is to test your model. So to test your model, this is the command, python main.py mode test only. Over here I'm using the test only mode, means I don't want a separate result.txt file in which I want to store the PSNR. I don't want that part, so I'm just using test only mode. And then you have to give the path of the folder on which you want to perform the testing. So I have one test data folder. Inside that folder I have a cars folder. Let me show you. So this is my test data folder, and in this folder I have placed all the images on which I want to perform the testing. Means I want to make their size, I want to make them high resolution images. Okay, in test data folder I have a cars folder. In a cars folder I have these 6 images. So right now the image size of first image is 259 into 195. So let me open that. So this is the image. So on these images, this is the second image, third image, fourth and fifth, sixth. These are the images on which I want to perform this SRGAN to make them high resolution images. Okay, so okay, let's go back to the code. So mode test only, I have given the path of the images on which I want to perform the super resolution. And then over here we are giving the path of our generator model. Okay, over here you have to give the path of your generator model, which you will get after training from here. Okay, now guys, while if you want to create a high resolution images from a low resolution images, right, then we only need generator. Discriminator is required at the time of training only. Once your training is done, generator is responsible to generate a high resolution images, right? Discriminator is only there at the time of training to help the generator to learn the process. But while in a real application, whenever you want to generate a high resolution image from a low resolution image, then you only need a generator model. So that's why we will use a generator model over here, right? And we will provide the images on which we want to perform this super resolution task. Okay, once you perform this command, output will get stored in a results folder. Let me show you the results folder now. So this is my result folder. Inside this, okay, I have done another task. Okay, maybe I have stored the results in this also. So you can see these are the images. Now let's open them. Now you can see the size is increased after 1600 epochs. We are getting this kind of image. Okay, now let me open the low resolution image also. Okay, so it is in, just a second. So we are opening a low resolution images also. So this is my low resolution image, and this is the high resolution we got. So this is the second low resolution image, and this is the second high resolution image we got. So let's see the third image, and this is the output image, right? Guys, you can see the size is increased 4 times, right now the quality of images are not very good, because we only I've told you, like, we have trained it for 1600 epochs only. You have to train it for more time to get a better results. But you can see this is the input to our SRGAN, and this is the output we are getting. Okay, let's see the next image. This one needs more time. Right now this image is not good, and this is the next image, right? This is the next image, right? So this is the input and this is the output of our SRGAN. Okay, so this is how you will get results, right guys? And if you want to learn about how SRGAN is working, the architecture of SRGAN, all that code is mentioned in this SRGAN_model file. You can see we are creating a generator class, then we have a discriminator class over here, right? So all the GAN networks have generator and discriminator. All that code is written in this file. So this is how you can run this SRGAN. And guys, I am giving the link of this repo in a description section, and you can try this code. And I have given the detail of environment setup also. Set your environment, and here is your training command, and then here is the test command. Okay. And one more thing guys, when you work on SRGAN, so sometimes let's say you don't want to create your own dataset, then you can use the dataset which are already available, like this div2k dataset. So here is the link of div2k dataset. You can download this data and then you can work on it. Okay, and I have trained my model on div2k dataset also, so the link of that model is over here. You can download this code, and simply by running this command, you just need to change the path of the the model where you placed after downloading. Wherever you are placing that model, just give the path of that and the path of the images, and then you can test the model. Okay, so you can use this pre-trained model also, just to see if the environment is set up properly, or if you want to try, then you can do it. Okay, so that's it guys. I hope this video is helpful. Thank you for watching.